At this point, you might know how to solve some quadratic equations where you can factor them, but you might not know how to solve all of them. In fact, some don't easily factor, and we have to come up with another way to do it. And that way is called completing the square. And before we talk about the ones that we can't solve, the quadratic equations that we can't factor, let's look at some stuff we do know how to factor. For instance, x squared plus 4x plus 4 is equal to 0. We might see that 2 and 2 add up to 4 and multiply to 4, so we have x plus 2 times x plus 2 is equal to 0. And that's going to be x plus 2 squared is equal to 0. And similarly, how about x squared plus 6x plus 9? We can factor that into x plus 3 squared. And in fact, for every, no matter what the x term is, there is some trinomial out there that'll factor into a square like this. Now, why do we want to factor in a square, and what does this have to do with solving any problem? Well, take this as an example. X squared plus 4 minus 7 is equal to 0. And we can't factor this easily. The only things that multiply to 7 easily are 7 and 1, and no combination of those will get us 4. So how are we supposed to do this? Well, the two strategies we're going to use are wishful thinking and analogy. Look at these two quadratic equations. The one on the left has a plus 4, and the one on the left has a negative 7. So they're alike in every single way, except for the fact that they differ in their constant term. We wish that we could make the one on the right look more like the one on the left, because we know how to factor the one on the left. That's simple. So what could we do to make the one on the right more like the one on the left? Well, we can add 11 to both sides of the equation, and then we're left with x squared plus 4x plus 4 is equal to 11. At this point, we know how to factor this. So let's factor the left-hand side. And at this point, when it's a square, we can take the square root of both sides. And remember that a square root will leave both a positive and negative square root if you're being serious. Often when you find a square root of a number, that's short for saying the positive square root. But every number has two square roots. And so we're left with the equation x plus 2 is equal to plus or minus square root of 11. And then by subtracting 2 from both sides, we get x is equal to negative 2 plus or minus the square root of 11. So I guess we could have added different numbers to both sides at the very beginning and got something else that we might have been able to factor, but only by having a squared term can we find the square root of both sides and get some sort of answer. And you might notice this isn't a very nice answer, and you probably would not be able to do this by any sort of guess and check method. This is not a really mathematical, rigorous definition of how completing the square works, but it gets the essential ideas down. I think in my next video I'm going to show the mathematical, rigorous way of doing it in any situation. But in short, the method is look at the x term, which is in this case 4. Think to yourself what the constant term must be in the corresponding simpler quadratic equation that we're able to factor easily into a square.